Here is another example of solving quadratic equation by factoring. Notice the difference between this example and the previous examples. Here is a leading coefficient. That's called a leading coefficient. Previously, we only had one there. There was no number here, which implies there's a one there. So there's a difference between this and the other one. This one's at the leading coefficient. So as before, the first step is to do this leading coefficient times 3. That's our first step. So we have 2 times 3 is 6, which we are going to go ahead and break into 2. Now notice that this is a negative 5. It's a negative 5 up here. To get a negative 5 from 6 with two factors that when you multiply them will be 6. There's no way you can get that. If you try to do 6 and 1, that's 7. If you do 2 and 3, that will be plus 6, but this is a negative 5. If you do negative 6 and 1, you'll get negative 5, but that will not give you plus 6. So the only combination of factors whose sum, addition, will be negative 5 is negative 2 and negative 3. Be careful with that. Now we've broken it up, so that will allow us to break this linear term into 2. So we can break the negative 5 into 2 as negative 2 and negative 3. That's basically what we did. We were doing. Now we have 4 terms. 4 terms. We can apply the principle of factoring by grouping. So we're going to group them. Okay, here's the grouping. We just group the first two. It doesn't matter really. You could have switched this up here and that over there. It doesn't matter. You can check it later on. We just group these two and group that two. As before, whenever there's a leading coefficient of a negative number here, and the third term, you have to put plus and then group this negative 3x plus 3 as one group without removing that negative to come outside. No. You put a plus here and then group all these two things together as one entity. So now we're ready to actually take out the common factor, which is our next step. So here x is common between these two. We're going to pull it out. Here negative 3 is common. Whenever there's a leading negative, we take it out first. So it's going to be a negative 3 that is common. So here's what I was talking about. So we took out the 2x, rather, not x. 2x is common. We took out 2x, and that leaves us with x minus 1. And we're taking out negative 3. Negative 3. That leaves us with x minus 1. You actually know you are right because this binomial factor should be the same at the end. See this factor here? They should be exactly the same. That's how you know if you're factoring well. This binomial factor is common. We're going to pull it out. It's going to come out from this group. It's going to come out from this group and also from this group. So we have x minus 1 is going to come out. So now x minus 1 is coming out, although I wrote it on the second side, but it doesn't matter. It's coming out here, and then what is left is 2x minus 3. That's the 2x minus 3, and then the x minus 1. And what is left is to set each of these to 0. We set this to 0, and we set this to 0 using the zero product property. And then we can just solve the remaining equation easily. We have to be 2x equals 3, divide both sides by 2. Divide both sides by 2, you get x equals 3 over 2. And then you also have x equals 1. So basically, to recap the process, whenever there's a leading coefficient here, it's a little bit different. Not too different, we just have to multiply that number by 3. And then we split this linear term into 2, and then we group. Only we have to be careful when there's a minus there, and then we can do common factor of negative 3, common factor of 2x, and then pull out the linear factor, linear binomial, the binomial that is common, and then take out what is left, and then set to 0, and then solve to the end. So hopefully this is clear, and you're able to make sense of it. All right, bye.